Hello everyone, welcome back. Part 2 of the TempleOS tutorial. And so what we're going to do in this tutorial is we're going to make this rectangle move around on the screen left and right. Now it's going to be pretty simple, but there's actually a couple different ways of doing it. I'm going to start by showing you the easiest way to do it because we like to do things that are easy here because we're lazy. Now, let me get right into it. So, one thing I didn't explain in the past tutorial was that if you have a menu open, like look at this is the grid menu. If you want to save your changes and exit, you just press escape, but if you want to abort your changes and exit, you press shift escape. So that's just how you do that. Someone was asking me about in the last video how to exit some of the menus, so that's how you do it. Now, we're going to get right into this game. It's going to be really simple. Like I said, we're going to move from left to right. So, TempleOS and Holy C, it is a object-oriented programming language, but it's also got some imperative paradigms from the C language. Since it's an object-oriented language, we can actually create classes, and that's what we're going to do. This is going to be our model for the application. We're going to need two classes, one for the keys. So we're going to have class keys, and we're going to store in it the buttons we're going to press. So I'm going to do left and right. And then we're also going to have a class player. And this is going to store the I64X variable. So that's going to be the player's position on the screen. It stands for integer, 64-bit integer. So we're going to initialize those. So keys equals, oh, I'm sorry, it's just we're not going to initialize it yet. We're just going to declare it like that. Okay, so player P. Next up, we're going to need the initialize function. And what this is going to do is refresh our model. So if we just say qinit at keys and qinit at P, that's going to refresh our classes whenever we run the initialization function. The next function we're going to need is the drawIt function. This is where the meat of the code is going to live. It's going to live in this drawIt function. This is how stuff gets drawn on the screen every frame. That takes this task, which is related, it's like a thread, and this DC, which is our canvas. So the DC is where our canvas is stored. We're going to come back to this function. The last thing we need is actually our main. So the main is where our code is going to start. Why? Because I say so. If you type main at the end here, it'll run the main function, and this is where we're going to start. Now every main function for the most part is going to look the same. We're going to do a few things. We're going to set the canvas alias to that DC variable, star DC. So that's our canvas stored in DC, and we're going to push the settings. We're going to set the window size to max. We're going to remove the cursor, remove the border, and clear the document. So this is just, if we run this now, we just get a blank. That's what we want, a blank canvas. This is where your dreams become representations on a monitor. Whoops. Oh, okay. If you're wondering what I have open on the left side here, this is my reference code. This is the Center app, which is available on my website. If you want to follow along and look at this as a guide, you're more than welcome to do that. Since I'm mentioning that, actually, if you press Ctrl-Alt-T, you can open a new window. If you also want to look at some of the other examples, it's stored in this demo folder here. Games. These are all the games that come with TempleOS. And really, if you're just starting off, Elephant Walk is a very basic app that just really takes keyboard input. Another basic one, it's not so much basic, but Castle Frankenstein has some good reference code for movement. So if you're ever struggling at any point and you need more examples, this is a good place to look. Anyway, let's get back to our main function. So we have our clear canvas. So what we're going to do now is finally actually initialize our model. So we want to start by saying, yeah, we're not holding any keys down. So, and we're going to set the player starting position to about the middle of the screen. So I believe it's 640 pixels in width. So that's about the center. Actually, it's about like 20 pixel rectangle. So that's about center. Anyway, next is we're going to tell our thread to draw. So we're going to point it to that draw it function, which is empty right now, but that's where we're going to do that, and then we're going to call our initialize. So we're going to start our thread and we're going to initialize the model. And now this is the main loop of the app. So the loop is redraw everything. If there's a song, make sure it's playing. If there's an animation we need to do, this is what the main loop is going to be. So we're going to have while true, and when the game is done playing, that's when we're going to exit this while loop. To make sure we can just easily exit the while loop as well as avoid system crash if we code something wrong, you want to wrap this in a try catch statement. So if we run into an error, we exit without the whole thing exploding. We don't want explosions when we're coding. If your computer blows up, you should reconsider what you're doing with your life. Anyway, right, so we're going to catch, and this catch is where we're going to have what we're going to do when the program finally quits. So when the program finally quits, we're going to clear the document again. We're going to put any exceptions, if there is any, on the screen so we know what went wrong, but we're not going to have any errors because we're ballers. Settings pop and menu pop. That just brings that back in the queue so that the regular TempleOS and menu settings are there. So while true, this is where we want to check every frame for our button presses. So to check for a button press, there's two. I mentioned, I think there's two ways to do it. We're going to do the simple way today. So the simple way to do it is switch on this get key function. What this get key function is going to do is it's going to check every frame if we have pressed a key on this frame. There are some better ways to do this, but for this video, I'm going to just show you the easy way. What we want to check first is a new line. So if you are at any way familiar with coding, \n means new line. In TempleOS, when we receive a new line in the get key, it means that nothing has been pressed. So we're just going to reinitialize the model if we don't have anything else to do. If we press the escape key, remember that's that save escape, and then there's also abort, which is the shift escape. So if we escape the application, we want to quit successfully, so we go to function done, or fs done, and fs done is just going to be a pointer in memory. So this is a real-time compiler, so just like in C, you can set a location. So if we press fs done here, it will go here when we press escape. So that's the escape key, that's how we quit. And if we do this right now, okay, well, we can't do it yet. I'll just keep explaining. I forgot to, for this SC, this is just going to be an integer, 64-bit integer SC. And that's going to store the result of what key press is on that frame. So if we run this now and press escape, we can actually exit the app now. So that is the escape key. The next key is actually, or the next case that we want to check is 0. So case 0, this is an array. So the navigation keys are returned as an array. Rather, it's returned differently. It's just how the operating system handles keyboard inputs. The escape keys are handled differently than alphanumeric and navigation keys. So case 0, that is going to be the group where the navigation keys are stored, and we're going to switch on that array. So if we press right, then we are going to set our keys .right equal to true. So we press the keys, and then we're going to break, and same thing for the left. Keys .left equals true. And that is it for our main function. So our main function is actually done. The last thing we need to do is our drawIt function. So this is where a lot of the logic actually comes in. Depending on what you're drawing on the screen, you might have to do a little bit of trigonometry depending on how complicated it is. Fortunately, we're just drawing a rectangle, so it's not going to be so hard. But this is what our drawIt function looks like. So first things first, if we have this button pressed, if we have the left key pressed, we're going to update the position of the player. We're going to move it 32 pixels to the left. Now, since you can't hold the left and right keys at the same time, I'm just going to put this in an else statement. If keys.right, then we're going to move to the right. P.x equals P.x plus 32. And if you're adding up and down, you would just add more if checks for however many keys or directions you want to move in. So that's that, and after we move the player, we're going to set the left back to false because we only want to do one movement per frame. Or per button press. So that's how you move the player. And then one last thing we want to do is just make sure that the player can't move off the screen. So if player.x is greater than the width of the screen, FS, that's our threaded, like I mentioned, it has some other, this is the structure for the application that stores the width of the screen. So if our player has moved beyond the bounds of the screen, set their position to slightly less than it. Similarly, if it's too low, I'm doing 550 here even though it's 640 just to add a little bit of a border, but you can set it to 640 or just to have, depending on how close you want the player to be able to get to the edge of the screen. I'm going to just set it to that. So now that the player position is correct, we are going to actually draw the rectangle on the canvas. So Sprite 3D draws a sprite on DC, our canvas, at position player.x. We don't have up or down movement, so I'm just going to put it around the middle of the screen, 300, and this is the z coordinate, which is 0 because this is a 2D game. And this part, if you press Control R, you want to add a pointer to that sprite. It should be in bucket 1, but if you made multiple sprites, you could change it here, and you also want to change this bid number. Press escape, that'll add the pointer, and we just close it. So that's our code. If you press F5, there's our square, and if you press left, you move left, and if you move right, you move right. Woo, yeah, TempleOS coders. It's that easy, guys, you know? It's really not that hard. So in the next video, I think I'm going to explain maybe how to do some animations, how to do some more fluid motion so you don't have to press the buttons down so much. But that'll be it for this video. So thanks for checking it out, and